Okay, we're going to be carrying over from lesson 20. We have a different learning target today for this lesson, but it's kind of the same thing that we did in lesson 20. It's just you creating more of your own fractions. So you're going to generate simple equivalent fractions by using visual fraction models. So the models are just what we draw, the rectangles or the circles whenever we're making our fractions. And the fractions that we're working today are equivalent fractions, so they're equal fractions. Okay, when you're looking at the models on the screen, and you can see what is shaded orange for the top two rectangles and what is shaded orange for the bottom two rectangles, you can see that they both have the same amount of space shaded, so that tells me that those are equivalent fractions. And at the top we have 2/3 and 4/6, and those are equivalent fractions. And then on the bottom we have 1/2 and 2/4, and those are equivalent fractions. But what I want you to look at is, what do you notice, or do you even notice a relationship between the numbers and the fractions? And I want you to see where I put the arrows. What do you notice between the 2 and the 4 and the 3 and the 6 from the top fractions? Or what do you notice when you're going from 1 to 2 and when you're going from 2 to 4? What are they doing to the numbers in the first fraction to get to the numbers in the second fraction? So I want you to push pause, and I want you to think about, what relationship do you see with these numbers, because this is going to help you whenever we're figuring out equivalent fractions. So I want you to think about that. When you think you have the answer in your mind, I want you to push play. Okay, when we're looking at the top fractions, and I'm looking at the numerator of 2, and then I go over here and the numerator is 4, I'm thinking that in order to get from 2 to 4, you could add 2, or you could multiply it by 2, and that would get you to 4. When I'm looking between 3 and 6, I know that you can add 3 to get to 6, or you can just multiply 3 to get to 6, or multiply it by 2 to get to 6. So what I noticed with both of those numbers is that all they're really doing is doubling the numerator and denominator in one fraction to get an equivalent fraction. So when you look at the bottom fractions of 1/2 and 2/4, they doubled 1 to get to 2, and then they doubled 2 to get to 4. So you're going to see that in a lot of equivalent fractions where they're doubling the numerator and denominator to get a new fraction that is equivalent to the first fraction that is on the paper or whatever it is that you're using. So we're going to use what I just talked about, where we can double our numerator and denominator to create equivalent fraction. And we're going to do that on our paper today, whenever you're working through this with me. A lot of the time that we're working today is just going to be on the concept development and you working on your piece of paper and drawing exactly what I want you to draw. I'm not going to have a problem set with this lesson, but there will be an exit ticket for this lesson. So the first excuse me, the first thing I want you to do is put 1/3 on your paper and then draw a rectangle. And then also draw another rectangle right underneath that that is the same length, same size, and everything, because we're still looking at the same hole. And I want you to have your first rectangle divided into 3 equal parts. Since our denominator for 1/3 is a 3, that tells me that I have 3 equal parts. And on your paper, I also want you to write 1/3 in each part, since each part of this whole is 1 out of 3 equal parts. And once we have that, once you have that on your paper, we're going to double the numerator and double the denominator to see what fraction is equivalent to 1/3. So whenever I double 1, I know that that gives me 2. And when I double 3, I know that that gives me 6. So now on my bottom rectangle, all that I have to do is double my parts that I already had. So since I had 3 parts, I now have to make 6 parts. So really, if I was using this same rectangle, it would just be me drawing a line right down the middle of each one of the parts because you're doubling that, meaning you're making each part have two parts now. So now on my rectangle down here, I'm just going to double it and draw a line right down the middle where I'm breaking apart my thirds now into 6 equal parts. And I also want you to label each unit fraction on your rectangle as 1/6 because each part is 1 part out of 6 parts altogether. And then we're going to shade to see if 1/3 is actually equal to 2/6 and if the doubling your numerator and denominator does work whenever you're trying to find equivalent fractions. Because it's always nice to know an easy way to find the answer, especially when we're working with fractions. So on your paper, I want you to shade in 1/3, and then I want you to shade in 2/6, and we're going to see if those are equal to the same amount, and if they do have the same amount of space that is shaded, then we know that these fractions are equivalent. And as you can see on the screen, and hopefully as you are doing it on your paper, you can see that yes, we do have the same amount of space shaded. So that does tell me that 1/3 and 2/6 are equivalent. Now the only thing that I'm going to say is if you're not really drawing your parts in your rectangle equally and making sure that your lines are where they need to be and that each part is the same size as the other part, then you're not going to be able to really tell equivalent fractions that well because the word equivalent means equal, and so all the parts have to be the same size whenever you're drawing your rectangles. So let's move over here to 4/8. Once again, you're going to need to draw two rectangles, both of them the same size, and we are going to divide our first rectangle into 8 equal parts because our denominator of our fraction is 8. And then we're also going to need to label each part of our whole as 1/8 because each part is 1 part out of 8 parts total. So get that drawn on your board or on your piece of paper, and then we'll be ready to move on to see what the equivalent fraction is for 4/8. Okay, so your top rectangle should look like this, where you have 8 equal parts and that you labeled each part with 1/8. But something that I'm going to do different with this one, instead of doubling our numerator and denominator, we're going to try dividing it by 2. But I am going to say right now that this is only going to work, dividing it by 2, if both numbers can be divided by 2. So if I had like 5/10, I couldn't divide 5 by 2 because whenever you're skip counting by 2's, you don't say 5, so that wouldn't work with that fraction. But since I can skip count by 4, or since I can skip count by 2's and say 4 and 8, then this will be able to work with this fraction and I will be able to divide it by 2. So if I divide 4 into 2, that gives me 2. Because whenever I'm skip counting by 2, I say 2 times and that gives me 4. So if I'm doing 8 divided by 2, I know that that gives me 4. So my equivalent fraction could be 2/4. So now what we're going to do with our bottom rectangle is we're going to make 4 equal sections instead of doubling our 8 and making 16 equal sections, because that would take some time and it would take a little bit to make sure that our parts were equal. So it's not always doubling the numerator and denominator. Just remember that sometimes you can divide the numerator and denominator and still get an equivalent fraction. So now we're going to label each part 1/4 because we have 4 equal parts. And then we are going to shade 4/8 on the top part, and we are going to shade 2/4 on the bottom rectangle, and we're going to see if 4/8 and 2/4 are actually equivalent to one another. So make sure you're shading that on your paper and you can see if these two fractions are equivalent. If your parts are not equal, just like mine are, then you're going to need to make sure you're fixing that to make sure that your parts are equal so you can really see if these fractions are equivalent or not. And whenever I shaded the 4/8 and now I'm shading the 2/4, I can see that I am shading in the same area and that they both have the same amount of shaded space. So that does tell me that 4/8 and 2/4 are equivalent fractions. Okay, so we're going to be ready to move on. Make sure you have this finished before you move on. And we're going to do the same thing again. We're going to look at our fractions. We may divide it by 2, or we may double the numerator and denominator and just multiply the numerator and denominator by 2. So make sure that on your paper you are putting 2/4 is equal to something we don't know yet. And you need to draw your 2 rectangles that represent the whole. And your first rectangle needs to be divided into 2 equal parts. Or not 2 equal parts, 4 equal parts, because the denominator is 4. And then when we look at the numerator and the denominator of 2/4, I want you to ask yourself, can you count by 2's and say 2 and say 4? And if your answer to that question is yes, then we can divide this by 2 instead of doubling it. So I'm going to divide 2 and 2 together, and when I divide 2 by 2, that gives me, let me fix this, that gives me 1. And then whenever I divide 4 and 2, that gives me 2. So this is telling me that 2/4 is equal to 1/2. And if you remember what I talked about in the last lesson, I said that if the numerator is half of what the denominator is, then that fraction is always going to be equal to 1/2. And when you look at this fraction, 2/4, you can see that 2 is half of what 4 is, so that does tell me that 2/4 is also equal to 1/2. But we're still going to use our model, and we're going to shade in and label all the fractions as unit fractions so we can double check to make sure we are correct. So make sure you are labeling your models on your paper and that you're shading in 2/4 and you're shading in 1/2 to see if these fractions are equivalent. If you want to push pause while you're doing that, you can, and you can check it once you're finished. So when you look at your shaded parts for what you shaded on the fractions for the fourths and the halves, you can see that 2/4 and 1/2 have the same amount of shaded space. So yes, those are equivalent fractions. And we did that by dividing by 2 instead of doubling the numerator and denominator, which is the same thing as multiplying by 2. So now on your paper, you need to be putting 1/4 is equal to something. We're going to figure that out. We're going to draw our 2 rectangles to represent our wholes. And our first rectangle is going to be divided into 4 equal parts. And you're labeling each unit fraction on that rectangle as 1/4. And we need to be asking ourselves if we are going to have to double the numerator and denominator of this fraction, or if we can divide the numerator and denominator by 2 to figure out our equivalent fraction. And when you're looking at 1, you have to ask yourself, can I divide 1 by 2? If you're skip counting by 2's, can you say 1? And the answer to that is no. So you can't divide 1 and 2 together. So what we're going to have to do is we're going to have to double the numerator and denominator. So whenever I double 1, I know that that gives me 2. And whenever I double 4, that gives me 8. Okay, so this is showing me that 1/4 is equivalent to 2/8. So what we're going to have to do down here is we're going to have to double our parts. So if we have 4 parts on this rectangle, we're going to have to make it into 8 parts. So that's kind of making our, well, let me show you something. You can make this have 4 equal parts, the bottom rectangle, and since we're doubling our 4 equal parts, then now all you have to do is make each part have 2 parts. So all you have to do is draw a line right down the middle. And that will give us 8 equal parts. And then once again, you need to label each part as 1/8. And then we need to shade in 2/8 and see if that is the same thing as 1/4, and make sure you're shading in 1/4 as well. So when you have all of your 1/8 labeled and you've shaded in 1/4 and 2/8 to see if these fractions are equivalent, I want you to go ahead and push play so you can check your answer with what I have on the screen. Okay, so your paper should look like mine does. I shaded 1/4 and I also shaded 2/8, and if you can see on your paper and on my screen that both parts that we shaded are the same amount of shaded space. So that 1/4 and 2/8 are equivalent fractions. Okay, before I move on, I want to show you a trick. Now that we've kind of learned what equivalent fractions are and you've learned how to make equivalent fractions by just putting a fraction and then doubling it or dividing it by 2. That's all we do when we create equivalent fractions for the most part. Sometimes you don't double it, sometimes you may multiply it by 3, or sometimes you may multiply it by 4. But anytime if you're asked to create 2 equivalent fractions, your best bet is just to write a fraction, a simple fraction that we've worked with before, and double it by 2. Because anytime you have to create one, they're not giving you a specific one to create. You just do it on your own and double it by 2. That's always an easy way to do it. But if you're ever given a fraction on a test and it says, okay, what's the equivalent fraction for this, and they give you some choices, I'm going to tell you a way that you can figure it out quickly and easily, and it's called cross multiplying. So I'm going to use 2/4 and 1/2 to show you. So you cross multiply the numbers that are across from each other. So you multiply 2 times 2. Oh, whoops. 2 times 2, which is 4. And then you multiply 4 times 1, which is 4. And you have to look at these two numbers that you got. This side is 4 and this side is 4. So if these two numbers are the same numbers, then that means that those two fractions are equal to each other. So let's go over here and try it on this one. Cross multiply again. Multiply the 1 and the 8, and I'm going to write it above here. That's 8. And then I'm going to multiply 4 and 2, and that is also 8. So these two numbers are both 8. So that tells me once again that 1/4 and 2/8 are equal to each other. So that's just a little trick that you can cross multiply both fractions and see if they are equal to each other. So that's you just checking your work. Because sometimes you may get a question where it says what is equivalent to 1/4, and they give you lots of options, but only one option is actually the right answer. So if you're not sure, you can always draw a model, or you can always cross multiply. Alright, so when we look at this next page, it says let's look at a different model. These three holes are the same. They each have the same amount of space that is shaded. I know that whenever you're looking at it, you're thinking, I don't really think they have the same amount of space shaded, but they really do. So when you're looking at this one, if I were to take this, and I'm going to unlock it because I'm going to show you something. Won't let me unlock it. Okay. If I were to take this fraction right here and I was to turn it the other way, where it was side by side with this one right here, you would see that this part that is shaded is also the same of this part that is shaded. So these two are equivalent. But when I'm looking over here, you might say, well, that doesn't look like it's equivalent to these two. But if I were to take this blue box and move it right up here, and if I were to take this blue box and I were to move it right up here, then this whole top row would be shaded. So just because they're in a different spot, it does not mean that they're not equivalent, because you can move these shaded spots around to actually where it would fit. So on your piece of paper, what I want you to do is I want you to write the fraction for what this is, what part is shaded here, write that as a fraction. I want you to write the fraction for this parts that are shaded, and then I also want you to write the fraction for what these parts are that are shaded. So you're going to have 3 different fractions on your paper that represent each one of these models. When you have those three fractions written on your paper, I want you to push play. Okay, so this first fraction is 1/3 because we've got 3 equal parts and 1 part is shaded. This fraction is 2/6 because there's 6 equal parts and 2 of those parts are shaded. And then this fraction is 3/9 because there's 9 parts altogether and there are 3 different parts that are shaded. So what this is saying is that all 3 of these fractions, 1/3, 2/6, and 3/9, are all equal to one another. So we're going to practice the trick that I just taught you of cross multiplying. So if I'm to take 1/3 and I'm going to move 2/6 over here by it after I get it unlocked because it won't let me move it, I'm going to cross multiply these. And so are you on your paper. So get 1/3 and 2/6 written on your paper. I want you to draw those arrows like I had. And we're going to multiply it. So if I'm multiplying 6 times 1, that gives me 6. And if I'm multiplying 3 times 2, that also gives me 6. So yes, that tells me that 1/3 and 2/6 are equal to one another. Now I'm going to take 2/6 and I'm going to move it over here with 3/9. And when you look at it, you're probably thinking, that doesn't really look like it's equal to one another because we haven't really worked with these two fractions a lot in figuring out if they were equal to one another. So we're going to do our arrows again. Make sure you're getting this on your paper. And we're going to multiply 9 times 2, or 2 times 9, however you want to think about it. And I know that 2 times 9 or 9 times 2 is 18. And when I multiply 6 and 3 together, that also gives me 18. So yes, this does tell me that 2/6 is equal to 3/9. And if you look, they didn't double the 2 because if you doubled the 2, you get a 4, and if you doubled the 6, you get a 12. So this fraction, they didn't double the numerator and denominator to get 3/9. So this is an example of where you don't always have to double the numerator and denominator. There's going to be some cases where they aren't doubled, but if you ever have to make your own, that's when I said you could go ahead and double the numerator and denominator. But don't forget this trick of cross multiplying so you can always check to see if two fractions are equivalent to one another. Okay, so I want you to look at this and I want you to write on your paper if this is true or false. Because it says 1 is equal to 2/2 and equal to 3/3. So what this is saying is all of these are all equal to the other one. So on your paper, I want you to put if that is true or if that is false. Okay, if you put true, you are correct. So what I want you to do real fast is I want you to draw 3 rectangles. They don't have to be huge. They don't have to take up a lot of space. But I do want 3 rectangles all the same size. And we're going to look and use this model to explain how this is actually true. When I have one whole, I don't have any parts. I don't have a denominator, I just have the number 1. So I'm going to shade in one whole rectangle because that's what this 1 stands for. This fraction says 2/2. So since the denominator is 2, that tells me that I'm going to have 2 equal parts. So I'm going to draw a line right down the middle to show 2 equal parts. The numerator is also a 2, which means that I have 2 parts that need to be shaded. So I'm going to shade both of those parts. And as you can see from the 2 that I have right here, 1 is equal to 2/2 because they both have the same amount of shaded space. Now I'm going to make my last rectangle have 3 equal parts. Make sure you're getting this down on your paper as well. And the numerator is a 3, which means all 3 parts are shaded. So all 3 of these parts are shaded. So whenever you are looking on your paper and you're looking on the screen, you notice that every rectangle, every hole, all has their same amount of shaded space. So yes, this is true because all of them have the same amount of shaded space. And we've talked before that anytime you see a fraction, and the numerator and the denominator are the same number, that is always equal to 1. So anytime the numerator and denominator have the same number, it's always going to be equal to 1. Okay, this one might be a little tricky, but I really want you to look at it and think about what it could be. But what I want you to write on your paper is, what fraction is shaded? So think about that and write that on your paper, and whenever you're ready to check your answer, you can push play. Okay, when you're looking at it, you notice that these three parts are all the same size, but when you're looking right here, this is not the same size as the others. So when we're looking at fractions, we need to have equal parts. So what we're going to have to do is we're going to have to make these other parts equal to this part. And all we have to do is draw a line right down the middle. Now all of my parts are equal. So the fraction that represented what the shaded part was is actually not 2. I don't know why I put 2. Let me erase that. Is actually 1/8. Okay, so if you put 1/8, you're right. If you put 1/4, I can see what you were thinking, but we had to make all the parts equal in order for the fraction to be correct, because we know with fractions you have to have equal parts. But I just wanted you to see that, because that's one of those problems where you really have to think about what you're going to need to do in order to get your answer correct. It wasn't 1/4, it was 1/8. You just had to make all the parts equal. Okay? I'm going to let you do this one on your own, but it's asking what fraction is equivalent to 1/4. So that means what fraction out of A, B, C, and D is equivalent to 1/4. So what I'm going to have you do, and what you should always do if you see this type of problem, is out beside each model, write what that fraction is. So this one is 1/2. B is actually 1/3. C is, there's 8 equal parts, so that's 2/8. And then D is 2/4. Okay? So, you actually have a few different ways that you can solve this. You could draw a circle and divide it into 4 equal parts and shade in one of those parts and see which one of these has the same amount of shaded space. Or you could cross multiply 1/4 with 1/2. You could cross multiply 1/4 with 1/3. You could cross multiply 1/4 with 2/8, or you could cross multiply 1/4 and 2/4 to see what it is actually equivalent to. So on your piece of paper, I either want you to draw a model to represent 1/4 and see if any of these have the same space that is shaded, or I want you to cross multiply 1/4 with these fractions on your paper to see which one is actually equivalent to 1/4. Whenever you're ready to check your answer, I want you to push play. Okay, so the correct answer is C, because 2/8 and 1/4 have the same amount of shaded space, and if you were to cross multiply them, they would be equal to one another. Okay, we're going to be ready to move on to the exit ticket. This says to draw and label 2 models that show equivalent fractions. So we did this a lot during this lesson. Pick a fraction, draw a model for it, and then write the fraction that is equivalent to the fraction that you wrote first, and you draw a model for that as well. And make sure you're labeling it like it says. So whenever you're done, and you explain why those 2 fractions are equivalent, you may bring me your exit ticket so we can look at it together.